Hi, this is Alex from devstories.eu, learning DSPy, episode 8 of 15. Suppose you write a piece of software, and instead of manually tweaking its internal logic to pass your tests, a compiler automatically rewrites the instructions so the program performs better on its own. You do not touch the code, you just provide the test set. That is exactly what DSPy does through a concept called optimizers. Optimizers, which were previously called teleprompters in older versions of the framework, are algorithms that tune the parameters of your program. In traditional machine learning, parameters mean neural network weights. In DSPy, parameters primarily mean the actual prompt strings and instructions sent to the language model, though they can also include weights. The optimizer's job is to adjust these parameters to maximize a metric you have already defined. This process happens before you deploy your application. It is pure pre-inference time compute. You spend processing power up front to find the best instructions so your application runs accurately later. When you hear the word optimizer, you might assume you need massive datasets like you would for fine-tuning a traditional model. You do not. Prompt optimizers are highly efficient. They typically require only 30 to 300 examples. Because the dataset is so small, DSPy recommends an unusual approach to splitting your data. Instead of the standard 80-20 split where most data goes to training, you flip it. You use 20% for training and 80% for validation. If you have 50 examples, you give 10 to the optimizer to build the prompts and use the remaining 40 to evaluate if those prompts actually generalize. This reverse split prevents the optimizer from overfitting the generated prompts to a tiny set of inputs. Here's the key insight. The iterative development cycle in DSPy revolves around running this optimization loop. Let us walk through a concrete scenario. You're building a basic question-answering bot. First, you define your DSPy program and your metric. Next, you gather your dataset of 50 unlabeled questions. You split this data, passing the small training portion to an optimizer object. You tell the optimizer to compile your program using your training data and your metric. The optimizer runs experimenting with different prompt structures under the hood. It checks the outputs against your metric, learns what works, and refines the prompts. When the optimizer finishes, it returns a new, compiled version of your program. This compiled program contains the newly tuned parameters. You do not need to run this optimization step every time your application starts. Instead, you call the save method on the compiled program, providing a file path. This writes all the optimized prompts and configurations to a standard JSON file. When you deploy your application to production, your code simply instantiates the base program and calls the load method, pointing it to that exact JSON file. Your bot is immediately ready to answer questions using the optimized instructions. The true power of DSPy optimizers is that they decouple your application logic from the exact phrasing of your prompts, letting computation find the best words for you. Thanks for listening. Happy coding, everyone.